Hey everybody, this is Nick Christian with CAT Global Dealer Learning. Thanks for joining us again on this episode of Electronics. We're here in the awesome Miami Lakes Learning Center, and today we're going to be talking about troubleshooting a -4 code on an active analog sensor. So as you can see, we've got a C15 industrial engine. We're going to be using this engine today to talk about this troubleshooting. So before we get too deep into the troubleshooting, I want to make sure we understand when we say active analog sensor, what does that mean? Okay, active sensor. An active sensor requires power from the ECM in order to operate properly. In this case, we're dealing with a 5-volt sensor. Okay, analog sensor. What does analog mean? Analog means that the signal from the sensor to the ECM is going to be a variable DC voltage that is going to change based on the parameter being measured by the sensor. So in this case, we're dealing with a boost pressure sensor. So as this sensor detects boosts, more or less, the DC voltage coming from the sensor to the ECM is also going to vary based on the pressure being detected. So in our example we're going to be looking at, we're using the boost pressure sensor out on that C15 industrial engine we've got down here in Miami Lakes. So that sensor, just as an example, let's say it has the ability to measure 0 PSI all the way up to 60 PSI. So the sensor itself, as it's detecting somewhere in this range our boost pressure, the signal from that sensor is going to output somewhere between 0 to 5 volts. Now we don't use the full 0 to 5 volts, we kind of put it somewhere in the middle. So on the low end of the scale, key on engine off in this case, 0 PSI, if it's detecting that, the sensor may put out a signal of half a volt. On the top range, if we're measuring 60 PSI, first of all, our engine's really working good. But if we're measuring 60 PSI, the sensor may be going out to, 4.5 volts it's gonna be measuring, okay? So we said an analog sensor is going to put out an analog signal that's going to be a variable DC voltage. So as we go from 0 PSI that we're detecting all the way up to 60, voltage-wise, that the sensor is going to be sending to the ECM, that the ECM reads, is going to be going from typically 0.5 volts up to typically 4.5 volts. So what we've got, as long as the ECM sees a voltage somewhere within that typically 0.5 to 4.5 range, right? So anywhere in here, if the ECM reads that, guess what? He is happy. He is a happy ECM, and he says no codes. All we're gonna do is, I'm reading a voltage, I'm reading a voltage, I'm reading a voltage. That's what ECMs like to do. They like to read voltages. And then what do? They take the voltage and they equate it to a pressure, right? In this case, based on the software, okay? So an FMI-3 code, the description for that code is voltage above normal, okay? What's normal? Normal to the ECM is he's happy, okay? If the ECM detects a voltage above normal, so anything above this 4.5 range, this is where we trigger a -3 FMI code. FMI being failure mode identifier. So it's giving us an indication as to what the failure mode that it's detecting is. In this case, voltage above normal. Okay, so we talked about the voltage range of this active analog sensor here and what happens when the ECM detects a voltage above normal. We get that -3 FMI code, okay? So what happens on the other side of that? A -4 code, all right? The ECM is gonna trigger that code if it detects a voltage below normal, in this case below normal being half a volt, okay? And we get that -4 FMI code in that scenario. Most FMI-4 codes are going to be the result of a short circuit condition. It's going to bring that voltage down to a voltage outside of the happy range of the sensor. So now that we understand what a -4 voltage below normal code means, let's start in on our troubleshooting. We've got 5 suspects that could be the root cause of the problem. So it's kind of like we're playing detective here, right? What are the 5 suspects? The power wire to the sensor, the ground wire to the sensor, the signal wire from the sensor to the ECM. The sensor itself could be failed, or the least likely, the ECM has failed. So we're going to go through the troubleshooting steps here that's going to lead us to who's causing our actual root problem here. So the scenario we're going to go through is we have an active -4 FMI voltage below normal code. Okay, so the first step that we are going to do when we have any problem with any active sensor is check for power. Okay, so on this 3-wire sensor, On the A wire is our 5-volt analog supply coming from our ECM. The B wire is our return, also provided by the ECM, and the C wire is the signal from the sensor going to the ECM that's giving us that variable DC voltage that we're looking for. All right, so we go to check for power between pin A and pin B on this 5-volt sensor. What we should see is 5 volts, plus or minus half a volt in this case. So we're seeing that here. This tells me that this active sensor does have the proper voltage coming from the ECM. So what does that do for me? Our 5 suspects, power to the sensor, ground to the sensor, guess what? Those 2 off the list. They are not the cause of the problem here. We're down to 3 suspects that could be the root cause of our problem here. Now that we've validated the power going to the sensor, our next step is going to be creating the opposite condition out at the sensor. So what's our code? -4 voltage below normal, okay? We know that that is most likely going to be the result of a short circuit condition. So to create the opposite, what are we going to do? We're going to make an open circuit condition. The easiest way to do that is to just go out and disconnect the sensor. So with the sensor disconnected, what I would expect to happen is CAD-ET would tell me that I have a active -3 code voltage above normal. That's what the ECM should be reporting at this point. Okay, so we've made our open circuit condition out at the end of the harness, and we've checked the active code on CAD-ET. If at this point our -4 code disappeared and our -3 code appears, what does that tell us? Well, when we connected the sensor back up, if our -4 code comes back up again, and when we disconnect it, the -3 code disappears. So every time I plug in my sensor, I get a -4 voltage below normal code. So that scenario would tell me that the sensor, the short circuit I'm searching for, is somewhere inside the sensor, and I go ahead and replace my sensor at this point. So let's change that scenario now. If we made our open circuit condition and we waited our debounce time, and the code did not change from a -4 to a -3, well, what would that tell me about my sensor? I've made an open circuit condition, and from this point all the way back to the ECM is still reporting that it has a -4 voltage below normal. So nothing changed in our circuit when I disconnected the sensor. In that scenario, that tells me that my sensor is not the root cause of our issue. Where are we going to go next? We're down to troubleshooting the signal wire or the ECM. So we're going to go down to the ECM. So in this case, it's easiest for us to go ahead and troubleshoot the ECM. So we made the opposite condition out at the harness with the sensor not installed. We're going to use that exact same logic, only now we're going to do that at the ECM. So first thing I need to do is look up the schematic for my engine here, okay? So we need to find out, where does our signal wire from the sensor enter into the ECM? Which connector, which wire do we go at? So we've identified that. Remember, we're dealing with a -4 voltage below normal code, and we've eliminated the sensor as being a suspect here. So at this point, we want to make that opposite condition again, only this time we do it at the ECM. So in order to do that, I'm going to need a little bit of help. Let's see, do we have a, oh, there it is. Ah, yes, wire removal tool. Thanks, assistant. So at this point, we're going to create an open circuit condition at the ECM. All right, so we've made our open circuit condition. Now, what do we expect the ECM to do at this point? If we create an open circuit condition, I would expect to see a -3 voltage above normal code. So if that happens, I started out with a -4 voltage below normal. I make an open circuit at the ECM. If the code then changes, what would that tell me? The ECM is recognizing the change that I made, and it is not the source of the problem. So we've eliminated the power wire to the sensor, the ground wire to the sensor. The sensor itself is not at fault. Now we just validated the ECM is also working the way we expect it to, so what's left? At that point, the signal wire in the harness would be the root cause of the failure. Okay, so let's back up a step and change the scenario. I made the open circuit at my ECM, and again, I wait my debounce time. And I wait, but yet I still have a -4 voltage below normal code, even though I've created an open circuit condition. Now in that scenario, it tells me that the ECM is not recognizing that I'm making this open circuit. It's telling me there's still a short circuit somewhere, and now we've gone as far as we can go. The ECM at this point, somewhere internally, has a short circuit condition, and we're going to go through our ECM replacement procedure. All right, everybody, thanks for joining me on this episode of Electronics from down here in Miami Lakes. As always, if you're interested in taking any of our electronics troubleshooting courses, don't forget, you can go out to here, all right? And once you get there, use the search function. Make sure you search for this course here, our electronics troubleshooting course. Once you've taken that, you can then sign up to take our Electronics Troubleshooting 2 course. So once you've been through both of those courses, we're going to run you through all kinds of hands-on scenarios, get you guys really comfortable and confident in troubleshooting all kinds of electronic issues that you may run out to in the field there. So thanks again for joining me, and as always, don't forget, if you're nice to the electrons, they're going to be nice to you.